Start recording. Start streaming. It's connecting. Okay. Yep, I'm gonna tweet the stream as soon as I see it come up on the webpage. Which is now. All right. All right, and I tweeted it, and I think I'm ready to talk about what I did. So, hello everyone, I'm streaming again because I actually wanted to keep doing what I was doing earlier, the earlier stream. Another reason is because this is my first time streaming with Twitch, as far as I know, and I didn't have the automatic archive setting turned on for my channel, so I lost the video for that stream I did. So I'm streaming again. I haven't eaten all day, but I'll be fine. Alright, so I went over some things I'd worked on in previous streams. One of them was Herms, the Haskell recipe manager. I have a fork of that at bytemyapp/Herms, and that was the last thing I streamed before today, so I didn't want to do that again. I had stuff for LorePub, this project, and everything in the issues that I need to do kind of requires a little bit of research and a bit of thinking, and I didn't really want to stream myself just kind of reading documentation on RSS feeds. So I decided to work on a project that I had thought about kicking the tires on a bit. And that is, so I've got Bloodhound, which is this Haskell library I wrote for talking to Elasticsearch. Elasticsearch is a search engine, search server, data store, whatever you want to call it. Basically, you just index documents on Elasticsearch, and then you can search their contents. Full text search, proper full text search. You can write your own and term analyzers and all kinds of stuff. So, the thing is that Bloodhound is just for Haskell, and I've been poking around with Rust a little bit lately, and I wanted to try writing something like Bloodhound, but in Rust. And I had been kind of waiting for a particular dependency I was going to need called hyper to eventually port itself to an async library called Tokyo, because that was going to be the big API breakage, the big change that was going to happen with hyper. So I was waiting for that. That's happened, and I had actually already ported a utility of mine that uses hyper called Lefertovo, which just fetches gitignore files from the GitHub gitignore repository. If you've never seen that, by the way, it's really helpful. So the GitHub team has their own GitHub org, and under that is the gitignore repository, and this is where all of the kind of the default gitignore files live. The main ones I use on a regular basis, the Haskell gitignore file, and the Rust one, of course. And my little utility just grabs the file over HTTP with the HTTP client from Hyper. And so what I want to do was port Bloodhound to Rust and just kind of get a sense of how that feels and what it's like. I got a start on it. I named it Duke for now. I'm not going to publish it to crates.io until it's actually something people could or should use, because squatting isn't okay. And from what I could tell from their community documentation, they don't want people to do that, so I'll respect their wishes, and I just won't take the name, and I'll hope nobody watching the stream takes the name while I'm working on this. So, I started by, what I wanted to do is do a vertical slice of the functionality initially. So a vertical slice here, I got the term from game development. And basically the idea is that instead of doing everything kind of breadth-wise, so the way to do this breadth first wise would be to essentially take a data type from Bloodhound, and let me see here, package, Bloodhound, types, data, search. So, whoops. There it is. And the search type has a query body, filter body, yada, yada, yada. So breadth first would essentially entail implementing every single one of these sum types. This query type is a sum type. It would mean implementing every single one of these types and all the different JSONs is everything all at once before I really did anything else. A vertical slice, instead, what I did is I picked the simplest possible thing that I could do, which in this case was a match all query, which has almost nothing to it. It's literally just maybe boost, and boost is just a double. It's just a 64-bit float. And get that working for talking to an Elasticsearch server, right? So accordingly, I made an enum called query. I gave it a data constructor called match all. Match all takes a single argument match all query. I have a struct called match all query. It has a field called boost, which is an option, which is what Rust calls maybe. Then I have a boost new type, and the boost new type is just, a 64-bit float, a double, right? And then what I've been essentially kind of striving with here is just remembering how module scope works. I forgot that, for example, if I go over to my test.rs here, you see how I do query : match all? So that's that data constructor right there. In Rust, you always use your enums qualified. So even though I imported query from Duke, I still have to qualify match all. That's fine. I don't really mind that much. Okay. So one of the things I've been striving with is getting this library called Serde, S-E-R-D-E, which stands for serialization, deserialization, to generate the JSON in the correct manner that I want. I expressed some discomfort earlier with the idea of using CodeGen expressly for JSON. In this particular case, I mean, for applications, I don't care as much, but when the whole point of a library like Bloodhound is to essentially define, so this is Bloodhound, this is Haskell code now. The point of Bloodhound is to define things like this, where it says explicitly what the JSON should look like and how it transforms or pulls in the data from the data type into that instance. Admittedly, a lot of the code is rote and could be generated, but that was how I felt when I wrote the Haskell code, and that's how I'm going to continue doing the Haskell code. However, in the Rust community, it seems like Serde is super common, and even if I wanted to define my own serialized instance, for example, serialize isn't specific to JSON, even though I'm actually using the Serde JSON crate here. That actually doesn't really matter. It doesn't matter that I have JSON in mind, because Serde is general to all serialization and deserialization. So the semantic value of defining the instance manually is somewhat diminished here, because I would still be speaking in terms of generic sequences and maps and things like that. And I could, I could write the Rust code like this. I could write this in Rust, omit nulls. I already found an example of that earlier tonight, where somebody filtered keys out of a map where the value was none. Right? I've already seen that. I know how to do that in Rust. But my reasoning was that this is the way the Rust community likes to do things, and I want to try to do things in the more standard, expected, kind of community standard sort of way. And also my thinking is that if I start out by using the shared serialization, deserialization, if I change my mind about how I want to do things later, then I just write the code. Whereas if I wrote the code up front to serialize everything manually, and then change my mind later, then I've done a bunch of wasted work, right? So I'll start out with it doing this way, and then I'll worry about the rest later. All right. So going back to my test, what I was testing was I had this problem where if I have a match-all query where boost is none, then the way that should look is like that. It should be an empty object. And then if boost is there, the object should have the field boost. Excuse me, sorry. So if I do cargo test here, whoops, I'll just do make test because I have no capture turned on. That's exactly what I get. So that's actually correct. But the only reason it's correct is because I added this skip serializing if, and then I called out to option is none in order to check if the option is none. And if that returns true, then shared isn't going to serialize this field. It'll just drop it. And that's exactly what I want. So that problem having been solved, I'm going to clean this up a little bit. Now, I've got a couple options of where I can go with this. The first thing I'm going to do, I think, actually, is let me see here. Do I have Elasticsearch installed? No. All right. So I'm going to go to elastic.co, downloads, download, general availability release 5.5.0. That seems fine. I generally just grab the tarball. I don't get a Debian or an RPM package because I don't really want to do a system installation of it as a general rule. Excuse me. And there's a few reasons for that. One is that on Bloodhound, for example, we maintain two different versions of the API, one for Elasticsearch 1.x and one for the version 5 series. And I can't really easily switch system level Elasticsearches without just like dumping an installation and reinstalling a new one. Accordingly, it is easier if I just keep them in their own little directories like this and just run them manually from there when I need to run a test for Bloodhound or something. And could not find executable Java. Okay, fair enough. OpenJDK should be fine for this. And let me see here. OpenJDK, we want OpenJDK 8, I think. Sudo apt install. Good to go. Alright, so while that goes, I am going to yeah, there we go. Alright, Elasticsearch is running now. That's cool. Test query, match all, JSON. So what I'm going to do now is just check that the JSON data gets generated correctly. I need to edit this for some of the changes I made. Duke, match all query, boost, okay. No boost. Query, boosting query, let's make it like 1.5. It actually doesn't mean anything. I think the only reason boost exists as a field on the match all query is to weight it relative to things that actually have constraints. Because the thing about a match all query is that it literally just matches anything. I think it only exists as a utility to make recursive construction of conjunction and disjunction of queries nicer, because then you essentially have like a 0 or a 1 query. By 0 or 1, I just mean, like, you know, if you add 0 to anything, you just get x back, whatever x is, right? And similarly for multiplication, 1 times anything gives you whatever the thing you had back, right? So I think that's basically what match all query exists to do, or at least that's what I've used it for. You could use it to just make a cursor to scroll a document collection on Elasticsearch, but I don't recommend it. Elasticsearch's kind of flaky and weird, especially when you start touching a lot of data, so it's best to avoid it if you can. Alright. So now we've got these two different things. So what I want to do now is I want to write a test assertion. So let's see how we do that in Rust. Sared. And Sared test. Interesting. Oh, it's just support library. Sared. Where do the tests live in here? Tests. Test. Oh, there's some tests. Okay. Assert DE tokens. DE. Deserialize? I don't know. I assume so. Well, let's find assert DE tokens and see how they wrote that. Part of the reason I'm looking at Saired's examples here specifically is that all I'm really essentially doing here is testing serialization code, so, you know, I might as well look at what a serialization library does to test things. And it looks like the thing I'm looking for lives in here under assert. Assert D, yeah, so assert tokens is the closest thing. This is it. Yep. Okay, so a value, and then a list of tokens, or vector of tokens. I don't know what Rust calls their arrays. Let me see here. Yeah? Okay. Alexi says it's just array, which, you know, makes sense. Actually, yeah, Rust array. Arrays and slices, yeah. I thought, do they have, it's just a macro? Okay. Serializer, new tokens. If ser.remaining greater than 0, remaining token, ser.remaining, value serialized successfully. So I think I just want assert EQ for now, and I'll abstract things out later. So I'm going to try assert EQ, and I expect this to look like, ooh, I could use a quasi-quoter for the string. Sared had one. They had an example. You remember that, Alexi? Rust, Sared, JSON, macro. They had a JSON macro. Let me just find it. Yeah, I think it was JSON bang. I just need to find it. Yeah, there it is. Sweet. Alright, this is going to be a value now. So that's actually fine. That's fine. Because then I could just compare values instead of strings, and that's even better. So I'm going to do that. Let boosted query expect JSON, and then yeah, cool. Match all. Boost 1.5. And whoops. There we go. No boost. Query expect. I probably don't have to do it quite this verbosely, but it's fine. Okay. Assert EQ. Boosted query expect. And I don't. We'll borrow. The problem is assert EQ is a macro. What's the type of this? Assert EQ bang. Assert. Come on, this bottoms out into a type somewhere. Okay, I give up. Alright, so what I want to do now is instead of just string, I'm just going to do toValue so that it turns into the enum in the shared JSON crate. I'll show everyone what this looks like real quick. Value. Hold on. Where is it? Enum's value. So this is how they represent JSON data in shared JSON. And this is actually identical to the representation Haskell uses. Let me show you what I'm talking about. JSON, data.json, and value. Go to the source code, blow it up a bit. Whoops. Yeah, so if you take a look, that is functionally identical, except for the constructor order to that. Same thing. Okay, so now that we've done that, I will just, ooh, that's some interesting indentation. I wonder what happened there. Well, I need to rename that to boosted query anyway, but I would like to know why I did that. And then this is no boost query, and this is no boost query expect. I'm going to kill the print line, and I'm going to make test. Alright, cannot find macro JSON bang in this scope. Fair enough. Alright, where do I get it from? Oh, I have to slap macro use to get the macro. Makes sense. Okay, rerun it. Alright, binary operation equals equals cannot be applied to the type standard result. Alrighty then. I'll just unwrap them. It's a test code anyway. Can't compare shared JSON value with shared JSON. Oh yeah, fair enough. So I don't think this is going to work, but I'm going to try it without borrowing, and then probably what's going to happen is I'm going to have to borrow both of them. Let me see here. Incorrect closed delimiter. Incorrect closed delimiter. Oh, dang. It's right. That's cool. It got the error in my JSON code at compile time. My JSON data, I should say. And the test passed, which is nifty. Alright. So I didn't need to borrow them. That's interesting. Okie dokie. I mean, to be fair, I'm not using them after the assert EQ, so there isn't a reason I should have to borrow, but a lot of the time, especially as I'm still building up my mental model of how ownership in Rust works, a lot of the times when I run into a problem, my kind of go-to is slap an ampersand on it and call it a day. Actually, I am borrowing the thing I'm passing to toValue. I don't think it's going to work, but let's try that. See what happens. Well, there you go. Works anyway. Alright, yeah, because I'm not reusing boosted query after toValue, so it doesn't really matter, so I can just move it into toValue and it's fine. Okay, so that's one problem solved. So continuing on with our thought of doing a vertical slice, the next thing to do is to actually focus on the client functionality, because we already have something that generates correct JSON that we could hypothetically pass. Well, no, not complete JSON. So we have the query level. That's going to be this part here in Bloodhound. We have just that one right there. So the next thing we need to look at is implementing the search type, which is what maybe is contained under, and that is our next type. So I wonder, so data type ordering, code ordering, that kind of thing in Haskell generally doesn't matter until you use template Haskell. I am wondering to myself whether I might not be able to use pub struct search above where query is defined in a module where I'm using macros. Let's see if it works. And let's see if that compiles. It does. Cool. Alrighty then. And I'm sorry, Alexi, what'd you ask? I ran make test. Does that not rebuild the alright. Let's try it. Alright, so what I'm going to do is I'm going to modify this module, put a typo in there, and rerun it. No, it reruns the build. Yeah, that's fine. It's a reasonable question. So Alexi was asking if maybe the test had passed, the build had passed, because rerunning cargo test after modifying the module doesn't, he thought maybe it didn't rebuild the library. It seems to. It broke when I tried it right there. But no, it seems to do the right thing, which is good. Stack does the same thing. If you change the library, stack does automatically rebuild the library. Alright, so I have a basic search type, and I actually already have the that part, the query. I don't really need to do anything special for that. Excuse me. So the next step is take a look and see make sort. Let's have a look at the client. Yeah, make search is in here. That's interesting. So, oh, you know what? I need to make it option, because I'm not actually guaranteed to have a query every time. Okay. Rebuild, and now I need to take a look at the test code I have in Bloodhound and take a look at how I do things. So we've got some standard operations. I also need to, now that I think of it, I should probably make a type for the response I get from Bloodhound, but maybe not right now. Maybe after I send a request. So search tweets. Search tweets. Parse ES response, search by index. Test index, search by index. That's going to be in client, I think. Search by index. You can tell Bloodhound's been around for a while. We've really, actually, it's not even me. I haven't really done that much. I got the library going for a little over a year, but Michael Xavier's really stepped up on Bloodhound. He does most of the maintenance now. I basically exist just to tell people no. That's my job, being mean. Alright, yeah, okay. So basically I need to, for the client code, I need to write some stuff that constructs a URL. And all this is doing is just searching a particular index. So I'll go ahead and make an index name, new type, pub struct index name pub. Well, it's not going to be a slice, so I guess it's just going to be string, right? Excuse me? Oh, excuse me, sorry. Let me see here. Yeah. So just a regular string, and then so to give an idea of what the URLs look like that I'm talking about, let me bring up the Elasticsearch reference and show you the. So we don't care about document APIs for now. We will do that, but that's not really like super interesting. So search, there we go. So generally speaking, when you do a search, you're going to have underscore search and then maybe some optional query parameters on the URL, and then you're going to be posting a JSON body to the Elasticsearch endpoint. You don't have to specify your index and oh, I forget what the other one is. What's the other one? It's not schema, maybe? Index, schema, mapping, index and mapping, I think. So Twitter is the index and tweet is the mapping, I believe. But you don't have to. You can just do /_search. So what I need to do is basically pull in code that can do HTTP request. That's going to be hyper. Pub fn. Let me bring up Rust hyper documentation and see if they have a data type for describing an HTTP request. I know Haskell does. We do that in Haskell, but let's see what they've got here. Documentation released. Oh, sorry, excuse me. Wow. All right. Client. That's where I want to go. HTTP requests. Well, perfect. Okay. Method URI request. Seems pretty simple. Query string. Set body. Set proxy. Set method. Headers. Interesting. Doesn't seem like Hey Lexi, have you done anything with Hyper yet? Okay. I just want to double check here so that I do things right. Can you add query string parameters via some method, or are you meant to just embed it in the URI string? Maybe under the URI type? That doesn't 100% make sense to me. No, I don't think that's it. No, okay. Yeah, it's just for extracting it. Well, they do have the same query method on URI, though. See? So that's because I don't really like doing that sort of thing in strings. You know what I mean? Yeah, I don't really like doing it like that. I'd rather have something a little more structured. Haskell just does lists of tuples, where the first value in the tuple is the key, and the second value is the the value. You know, that whole deal right there. Another reason I want to do it that way is because then I can't forget to URL encode stuff. Let me search for Rust hyper URI query string. See what we get here. Query string URI discards query string making requests. That's terrifying. Parse the URL's query string query pairs. Well, I'm intrigued. Parse. This is under nickel. Join. Options. Wait, this is URL. And this is URI. Different version of hyper, maybe? Query string. Query. Get the query. They may just not do that. Do they have URL encoding? Form URL encoded. HTTP percent encode. It's under header parsing. Header encoding. Something doesn't seem quite right here. Doesn't it seem like something's missing here? Yeah, it's pretty weird. Let me back up all the way to the top over here. Make certain maybe the search isn't scoped. No, I think it was searching the whole thing before. That is really weird. Am I meant to use a different library and kind of glue it together? Rust query string. I just want to do it right, you know? URL parser. It's not quite what I need. High-level REST API client in Rust. 2015. Probably not. Sorry, the dog was making noise. Query pairs method into owned. Okay. So this is from the URL library. So I guess I'm still learning how to read documentation in Rust. And yeah, that, hold on. I want to look at the other thing. docs.rs hyper. I want to double check that I'm looking at the right URL type here. Struct URI. It's not the same thing. And it's not importing from anywhere. This is it. That's all they've got. Option usize. Wait, are you serious? Oh, that's funny. I think usize is it's unsigned pointer size, I think. So I think it's just meant to be an index into the byte string. So instead of storing the query string separate of the total URI, they just store indexes that they can dereference. I think so anyway. Let me double check what byte string is. Is this the right thing? Use common byte stir. Immutable sequence of bytes. Operations will not mutate the original value. Well, first I'd have to figure out what the unprefixed common means. Do you know what that means, Alexi? This extra colon in front of common? Okay, well, let's find out. Rust prefix colons. This is use. Use. Nope. Maybe. Probably the easiest way to find out where this comes from is to actually look up the Rust Hyper GitHub and then see if there's a common module or something. Source. Okay, there's nothing called common here, but I'm going to check under... Oh, there it is. So I think... Yeah, there's pub use self-stir, bytestir, mod.rs for common, and then there's bytestir, and it's a new type for bytes, and let's take a look at bytes, source, bytes. It is a reference-counted contiguous slice of memory. Bytes values facilitate zero-copy network programming by allowing multiple bytes objects to point at the same underlying memory. Is it an arc? Inner 2. What's inner 2? Inner 2 is an inner. And an inner is a pointer with immutable U8. A usize len cap. You know what that reminds me of? Actually, both of these types remind me of byte string, and I'll show you what I'm talking about. So if you look at the source for byte string, you'll see that it's a foreign pointer of word 8, an offset, and a length, right? Length, cap. And then when we go back and look at URI, it's just storing indexes into the same thing. So, same pattern. 3 different places, 3 different times. Alright, that's cool. I think they're doing it just to avoid having copies of data in memory, which, you know, makes sense, because, I mean, that's the justification in this thing, this bytes thing. Okie dokie. So I guess I'm just going to assume that what I want isn't a thing. So I'm just going to have to manually append stuff. But that means I still need to figure out URL encoding. I will just do the wrong thing for now, which is not URL encode. And I'll fix it later. I think that's what I'll do. Most of this stuff isn't relevant now, so I'm going to kill off some tabs here. And from stir. Yes. Okay. So what I'm going to do is start a public function. Let's see here. Well, I'm going to first see if I can successfully construct a URI. After I successfully construct a URI, I will see if I can construct an entire request for Hyper. After I get an entire request, I'll start manually constructing a request to Elasticsearch. Once that works, I'll start trying to serialize the JSON body for the request to Elasticsearch, and then I'll try to actually get a search to work. I'm just reminding myself what the syntax for a function is. Tells you how often I write Rust. Hold on, it's just pub fn. I'm gonna call this. You know what? I can even make this a test function. I can just do that, right? So test talk to server, and then I'm not gonna make it take anything. And I don't need to put an arrow there because it's not returning anything. And then I just need to start talking to Hyper, and start using Hyper. So the best example of that is here from Lefortovo. I can just reuse the code. Pretty convenient. So yeah, you can see the .parse, .unwrap. So fair. All right. So we're just gonna localhost. Where is this running? It's 9200. Localhost 9200. There's like a head. Yeah, there we go. All right. 9200 slash. Who cares? Put it there, but it doesn't matter for the moment. And then I'm gonna need to pull in pretty much all of that, with the exception of, I'm not gonna need clap because I'm not doing, whoops. I'm not doing command line stuff. I already have Hyper. I might need Hyper TLS, although I'm not going to use it for the moment, so I'll comment it out. I do need Tokyo Core. And then I'm going to create a Tokyo Core reactor. Man, that reactor thing's going to be a real pain later because the way we would handle something like reactor, HTTP client has a manager that serves basically the same purpose. And they don't have reader monads in this language, so you're just gonna have to argument pass that yourself, which kind of sucks. Not a lot I can do about it though. Alright, so I don't have a lang here. I'm just gonna zero that out for the moment. Then I'm going to I want to just print body, which is what that code is going to do, which I probably should abstract out into a function. I'm not going to do that for the moment. Oh, can't find create futures. Fair enough. Fair enough. Futures equals crates.io. Futures, futures, futures. Hit it again. Why is it mad? It's mad because no associated item from UTF-8 type stir. Yeah, so I'll explain why it's complaining, because I know why it's complaining. Or maybe I know. Multiple build found. Multiple use of undeclared typer module hyper TLS. Okay. Well, alright, where's hyper T? Ah, yeah. Okay. What I can do is I can try that real quick. See if it solves that problem. Ah, Alexi caught that I was editing the Life of Topo library. Thank you, Alexi. Alright, we want to edit this. And this might not be right, but I'm going to try it. Alright. I do. That part was intentional. Yeah, I couldn't find HTTPS connector. There we go. Wait for it. Could not find HTTP connector in Hyper. Okay. I'll just go ahead and use Hyper TLS. I didn't really want to do it just right now, but that's fine. Not really a big deal. Function is never used. Build URL. What? No method named and then found for the type. Hyper client. Future response. In the current scope. Cool. Let me think here. I think I ran into something like that in Life of Topo. But then I fixed it. Oh, you know what? I need to import from futures here, I think. Maybe. Imported to the previous. Yeah, okay. So what remains now is no associated item found for from. Yeah, okay. I need to import the method from standard stir, I think. Yep, I was right. Hey, look at that. Does that look familiar? Looks familiar to me. Alright, cool beans. So now we have the ability to construct a very rudimentary request for the server. Oh boy, I'm gonna have to make some decisions here because if we look at Bloodhound, you will see that it has something called monad BH. And monad BH is really like a very dumb kind of MTL style type class. It basically does two things. One thing it does is it tells you how to perform effects IO in some arbitrarily nested monad stack. The other thing is it tells you how to get a BHM, and then the BHM is this bad boy right here, and that has a server, which is the it's basically how you talk to it's how it knows what host name, basically. That's all it is. You can see it's just a text value. It doesn't really do anything interesting. The manager is the part I'm kind of thinking about right now. The request hook is just like a middleware hook we added so that people could modify requests arbitrarily if they needed to before performing the request. BH manager, that's tougher. That's tougher. So, excuse me, manager is like a connection pool that manages HTTP client connections. I think, although I am not certain about this, but I think Tokyo Reactor is managing a similar sort of resource for Hyper. So what I need to do is I first need to find out exactly what a reactor is and how it works. So let's okay. So Alexei mentioned people using the term, you said event loop? Event loop with respect to Reactor, so that might be a hint. I want to see what the documentation says here. This Reactor or event loop. Okay, this is more like Twisted than I thought, because that's exactly what Twisted is you have like these kind of Reactor-ish event loop things managing stuff. Alright. Okay. Let me see here. So it's an event loop. Returns a handle to this event loop which cannot be sent across threads, but can be used as a proxy to the event loop itself. Handles are clonable, and clones always refer to the same event loop. Its handles typically passed into functions to create I/O objects to bind them to this event loop. Okay. Well, I'm going to do things the dumb way for now, but eventually I would like to get to an API more like Bloodhound, where the user can provide their own manager or reactor or whatever it might be. For now, I'll just make it dumb, and that'll be fine. Alright. So, next thing we need to do is construct a request that has a JSON body. So if I do _search here, what is it going to give me? 0 results because I didn't really give it an actual query. But that is a valid response. Okay, cool. Let me see here. I need to figure out how to... I should figure out what the type of parse is. What's the type of parse? Parse. Not header. I want URI, or actually, is it request? Hold on. Parse? No. It's a string dot parse. I guess we're playing the game whose method is it anyway? Well, I know how I would solve this mystery in Haskell. I would assign a type to URL. Actually, I could also just look at client.get. Let's try that. Client get. It expects a URI, so it is constructing a URI. Wait a second. So it only has a get helper for get, but if I want to send a post, I think I need to construct a request. So I need to give it a method and a URI for requests. So I should change that. So let rec equals request and we'll do, where's method? method get for now, because I don't really want to change that much. And then request and rec, and we'll rerun it. Alright, what did I get wrong? Unused import future, unused import stream. Okay, I'm gonna clean that up just so it stops. Functions are used, pub, okay, pub. Oh wow, that's annoying. Seemingly can't fix these warnings and not get the missing for each implementation error. Use of this is a different error. I'm actually trying to get rid of these warnings, but it has to do with the futures import, and because I can't really see my type errors all that easily because the warnings are actually shoving them up. You see what I mean? Yeah, so I wanted to fix that. Alright, we're just gonna toss these in there and not get those warnings anymore because I don't care about them right now. Use of undeclared typer module. Yeah, sure. Use hyper request. So hyper method. Is that right? Did you mean request fields? Yeah, fair enough. Maybe I can call that new method. Nope. It's not the import at the moment. It's oh, I see. You mean this? Or do you mean? Okay. Nope. Because it's not a module. Yeah. No, that's fine. It's a good guess. I just, because basically the type constructor, the type is in scope now, and I am just expected value found struct request. So my current confusion is, let me go to the request struct here. Yeah, so it has impl request and then new. And I'm not using new correctly. And I don't know what I'm doing wrong at the moment. Because I don't really... Maybe I should do request : Oh, that was it. Yeah, because I wouldn't be calling it on the instance. I wouldn't be calling dot on a type constructor. That doesn't make sense. Use scoping, the module namespacing thing for that. Incidentally, it worked. So that's another problem solved. Okay. Alright, let's figure out set body. That seems to be what I need, right? Okay. So save that, do that, and rec.setBody JSON bang ser JSON to string JSON bang. Actually, I'll just use my type. Where's test.rs? And we'll do that. Boosted query. And this needs to be mute, I think. Does that seem right to you? The request has to be mute for me to mutate it like that. Convert from result. Right. So in Haskell, when you use to.json, it actually can't fail. It's just not a thing. But in Serd it is, because it's weird or something. Alright, I need to borrow boosted query. Actually, I should be doing this on search. Now that I think of it. Boosted query search. Search query. There we go. Boosted query search. Standard option. There we go. Use of undeclared type or module Duke. Yeah, fair enough. It's kind of already in here, isn't it? All right. I think that worked. Because I did boosted query search, I did set body to string, boosted query search, and I used that request. And I think it already worked. That's pretty cool. That was a lot easier than I expected it to be. Not really happy about the unwrap, but you know, I'll get there. Yeah, this unwrap bothers me too. I need to do something about that. Okay. Wow. Well, there's a vertical slice done, I think. I've posted a search based on a data type to the Elasticsearch server, and it worked. So let me do something here. Just to double check, I'm gonna, whoops. Yeah, okay, connection refused when I ran that. Okay, Elasticsearch. I'm gonna install a dashboard called head for Elasticsearch. It's a handy dandy little thing. Wow. Running as a plugin of Elasticsearch is now deprecated. Oh wow, Elasticsearch just, they got rid of site plugins? Oh my god, that is terrible. What is wrong with these people? Site plugins were amazing. They made it so easy to... Alright. Alright, Elasticsearch. It's not the head author's fault. It's, that's Elasticsearch. Man, that's brutal. Alright. cd Elasticsearch head npm install. And I'm going to get out of Bloodhound because I don't think I'm really going to use the REPL there anyway. I'm just going to get into Elasticsearch, run Elasticsearch again, and it's just npm run start and then open this guy. Okay. So whenever this finishes, Downloading all the JavaScript in the universe. Phantom.js? Why is it installed? Is it scraping Elasticsearch with Phantom.js? What is it doing? It's madness. Alright. Run start. Alright. There. Oh, cluster health not connected. What am I doing wrong? Yes. HTTPS? No? Okay. Does my REST code still work? Yes, it does. Yeah, no, it's supposed to be 9200 for the actual API, which is what this would use. Okay. Oh wow. It's trying to use the Netty protocol, the like raw Java protocol, and it's getting an error. You can see it in here. So I guess Elasticsearch head doesn't work anymore. Partly because Elasticsearch broke two different APIs, the Java API and the plugin API. That is obscene. I complain about how Elasticsearch APIs are really annoying and break all the time, but I say that as somebody who consumes the JSON API, but that's actually way more stable than what this guy was using. I feel really bad for him. I've used his dashboard for Elasticsearch for over half a decade, and I've never had to think about it before. Like previously I would just use the plugin functionality and install it automatically, and it would just work. Wow, that's kind of upsetting. Alright, what am I supposed to use to talk to Elasticsearch as a human being? Am I supposed to use Kibana? Okay. Analyzing data. Head. Classic dashboard includes Elasticsearch from the beginning. What? Is it built in? Am I supposed to... what? Where? What? It says head is included. A replacement for head called Kopf. Not all dashboards. Your cluster overview page shows what's available. Oh! It's included with Elastic Cloud, not with a local install. You fucking douchebags. Alright. So, head's working in their cluster, but I can't get it working on my local machine. That's nice. That's real nice. Officially available plugins. Official plugin. I thought they disabled the plug. Wait, 2.4.0. I think their documentation's old. Yeah, in Elasticsearch 5.0 and later, site plugins are no longer supported. This change does not affect the site plugins Elastic Cloud provides out of the box, but that doesn't help me if I'm running it locally. Oh man, I'm gonna get really salty. Oh, come on. Elasticsearch Kopf. So this seems to be the new hotness. So we'll try this instead. Kopf is no longer maintained. Okay. We're supposed to check out Cerebro now. Like, whole generations have sprung up and died since I've been not paying attention. Oh my god. This is crazy. Okay. Oh. Alright. Elasticsearch web admin. Okay, releases. This was released April 6th. So, it's not unreasonable for me to hope that this is going to work, right? Okay, Cerebro, tar, XCF. Incidentally, anybody watching the stream right now is finding out where my grumpy tweets on Twitter come from. losing more time figuring out how to just look at Elasticsearch than I did figuring out how to post a JSON body. Okay, bin, Cerebro, give it a shot. Default settings. Okay, listening on, so that's IPv6 localhost 9000. Okay, HTTP :// 9200. Connect. There we go. Alright, so the next question is whether this does everything I want. Create index. Twitter. Shards. 153, I think is the standard. It's gonna complain, but I don't care. Overview. Aha! There's my Twitter. And there's it whining about the unassigned shards. I'm not gonna fire up 4 more instances, so... or 3. Excuse me, whatever. I don't care. Alright, so now... I need... no, not index template. REST? Ooh, boy, this is not equivalent to head. So, Alexi, what I'm trying to do here is I'm trying to index a couple of example documents so I can query them from Rust. And they have some basic index management, but head actually had like some UI that would make it easy for you to insert a document and things like that. And it had specific little like helpers for different kinds of requests and you know, things you might do with the cluster. But what's repositories? I have no idea. Okay. Anyway, they don't really have anything like that. They have an overview, a nodes listing. They have a manual request performance thing, which is like does almost nothing. Right? Because it's just like I'm just putting in a JSON body manually and all that stuff. Ooh, boy. So it may be faster for me to just implement document indexing in Rust rather than typing this all out manually. This is not equivalent to head at all. This is really sad. Man. That is really disappointing. Okay. Well, that's what I get for having expectations, right? I expected something. That's what set me up to be disappointed. Alright. So I have to index a document. So, Elasticsearch, index document. Nope. Wait. 2x. 2.x. I think of the guide, not of Elasticsearch. Not that it should matter. Okay. Put index type ID. And then it's just fields and values. If you're going to use Elasticsearch properly, you really should set up a schema, mapping, whatever. Maybe it's under document metadata. Index type ID. Oh, excuse me. Types and mappings. Types and mappings. Types and mappings. Yeah. So this is a mapping in the data index. So in our case, the index would be Twitter, not data. And then under mappings, you would have a mapping called people. And then you'd have properties like name, type string, address, type string, and name and address are just fields. You can give it formats, so that you can specify exactly how things should be stored and how they should work and that sort of thing. You have to use mappings if you want things like dates to get handled properly, because JSON doesn't have a native date type, so it doesn't know it should parse a date out of a string until you tell it, right? You should also just not use Elasticsearch without mappings in production. It is an extremely bad idea. I realize I'm a little bit of a hypocrite saying this because Bloodhound doesn't actually do anything to support mappings, but I basically assumed everybody was going to do that manually anyway. And I also didn't do it because I kind of felt like it wasn't worthwhile doing mappings types unless I actually hooked them up to the queries and made them type safe, kind of like the way persistent and Escalito are. Does that make any sense, Alexi? But that would have egregiously complicated the actual query DSL, which is really the point of Bloodhound. So, or at least for what I know how to accomplish that. Well, Escalito is a fair bit more complicated than Bloodhound is. Some of that's SQL. Not all that's just the type safety, but I didn't want to do it until I knew how to do it in a way that would make me happy, basically. So, but I don't know. I'm going to leave mappings alone for now and just focus on indexing a document. So, let me see here. So, one thing is I'm going to have to keep talking to Elasticsearch, so I need to abstract this stuff out because this is getting a little crazy. Pub fn dispatch search request, and we're gonna get a well, it would be a string, really. That's gonna be, sorry, excuse me. Path. This is all gonna get changed a lot as I figure out how to do this in a way that makes me happy. So let me pull that out. And this is where path is going to go. So that is path. That means I'm going to change that type here in a bit. Alright. Dispatch. Search request. Search to string. I think is the right thing. And I need to move the rest of this out. And we're going to return S. So it's going to be string. I don't know if that's... Ooh. Yeah. Don't know how that's going to work out. Guess we'll find out. Okay. And we need a method for this guy. It's going to be method, and we'll actually just make this the whole URL, to be honest. So that'll be URI, I think. And no, I'll leave it string for now. And then, oops, URL, I'll fix it later. URL, method, and the JSON body. So what I need to do is I need to take an argument of JSON body option and then that's going to be T, and then it's going to be where T serialized T. I don't remember the syntax for this. I'll figure it out. Okay, then that's going to get moved out here, and it's string method boosted query search. Some boosted query search, and then I need to change this code so that if there is some JSON body, then we go ahead and set the request body. Right, okay. So what's the right way to do this in Rust? Let me think about this. Kill that. I'm not going to use that. That's my disk space. Pretty good, seemingly. Papu, stop. And this is going to be JSON body. I'm going to match JSON body. Let me see here. Rust match. Match. And I don't really want to do a let. Yeah, just a top level match. So match bracket some body arrow and I don't know how to do a do nothing. So eat it. Give it a shot. This is gonna have so many type errors. Cannot find type T in this context. Like that. Not found in the scope. Cannot find trait serialized in scope. Really? It's like right there. Okay. Use ser derive. Use serd. Can I find trait serialized in the scope? What? Use trait from crate in the same lexical scope. Do I need to use serd serialize? Be? Oh. Oh. Well, it helps if I extra and create serd, I guess, huh? Expected no type arguments. Okay. Expected one of... What did I do wrong here? I'm not supposed to... Yeah, you're right. Lexi said he thinks it's commas, and I think he's right. Ooh! That's spicy. Alright, so use of partially moved valued JSON body. Move occurs because blah 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 has type T, which does not implement the copy trait. Well, I didn't actually want to copy it, so let's borrow there for the moment and rerun. Ooh. Expected enum. Alright. Expected reference found enum. Yes. Cannot move out of bar content. Ref body. Oh, no, okay. Star and ref body? Do I need dereference match and ref body? I do. That was it. It was both. It was both of us. It was what Alexi said about ref body, and it was the star dereference on the match. And invalid URI for client request. Invalid. Oh, right. I need to build URL that. There we go. So that it's a valid request. And now it should work. And do basically the same thing it did before. And it did. It worked. Alright, cool. So now that we've done that, whoops. I'm surprised I remembered the where t trait syntax, how that worked. I didn't think I was actually going to remember that. I mean, I got the arity of serialize wrong, but who cares? Okay, so now what I need to do is pub fn test insert document. Actually, I won't make it a test. What I'll do is I'll make a setup and teardown function like what I do in Bloodhound. Kind of like what we were talking about with Ballast, right, Alexi, where we try to like set up data and then tear it back down. Yeah, so we're going to insert document, and it's going to take an argument of URL string. I really should fix that. And then it's going to take a doc of borrow t, I think, because it's not going to be option. And then I'm going to return the string response. And that's going to be where t serialize. And that's going to be this is basically the opposite of build URL, really, but that's fine. It's fine. I'm going to format URL with slash and then whatever the Elasticsearch URL was here. So it's index type ID. We're not doing a put, we're doing a post. We need insert, not index. Where's creating a document? Post. And it's just going to be it's going to be the index, and we're just going to do index for now and see if it works. See how that flies. And that looks silly, but that's actually pretty much it. URL, no, not URL, I can't shadow. Index URL, underscore. That's what we do here. Alright, and then we're gonna do dispatch Elasticsearch request URL and method post and some doc. And I don't want a semicolon there because I just want to return the string. And then now what I need is an example data type to talk about. So let's have a look at the tweet type that I use in the Haskell tests. Where's tweet? That's a tweet. Alright. I'm not going to do all that. I'm just going to do user and message. So struct, this doesn't really need to be public. I don't think it does need to be anyway. We're going to reuse that. Struct, tweet, and tweet's going to have username, and that's going to be string, and we're going to have message, string, and do I need to do anything special? I don't think so. I think I can just post any document. So let's try that. And then I need delete. I think the easiest way to do this is to actually implement create index. So where's create index? Index management. Put my index. Wait. Oh man, that versioning is confusing because they're talking about the guide, not Elasticsearch. Alright, deleting index is just delete on index. Yeah. Cool. Alright. So we just need pub effin create index, and we just need an index. I should change this to use index name later, but you know, later. This is going to be put still, and our request body is going to be none. Do I have to borrow the none constructor? I guess I'll find out. And URL, create index. Method put, and then we're going to do the same thing pretty much, but for delete. And it's just going to be delete, as far as I can tell. And I'm just going to make test real quick, see if that compiles. Not found in this scope because I didn't introduce a T. What if I introduce a T? URL not found in this scope. Sure, because I'm supposed to be using index URL, not URL. I'm actually supposed to be using index URL there too, and I'm not. I need to be more careful with that. Whoops. There we go. And URL is not found in this scope because it's not a thing. Well, oops. I just need it for everything because I need the host name. Delete index where T. Yeah, I don't need the where T serialized because I'm not polymorphically serializing something. Cannot infer type for T. Are you serious? I mean, this could happen in Haskell too. I guess. I mean, can I just do that? Oh, here, some empty string. This is a bad solution, but I just want to see if it's going to work. Ooh, it did. Ouch. Alright, I don't really like that solution because it's not really making good use of the option if I'm just going to use an empty string. So I need to figure that out. Alright, so now what I'm going to do is I'm going to create index, and that's going to be build URL empty string. The index is going to be Twitter, and I want to print this, so I want to print what this does. Alright, and then at the end I want to delete the index, and I want to insert document, and I want an example tweet. Example tweet equals tweet username by my app message. Hi. No. I know what to do for this. Tag Kaczynski Industrial Society is future. There we go. There we go. Yes. That's perfect. Alright. So we're inserting that as an example tweet. And then make test. Build failed, waiting for other jobs to finish. Expected, struct, string, found reference. Yeah, sure. I need to string this, I guess. So that and that. Expected string, delete index. Need to give that the same treatment. Make test. Expected reference, found struct tweet. Right. Alright. Ampersand. Just going to ampersand our way to victory here. Expected struct. Oh, yeah. I have to string my username and Ted's words. Now we make a reference to, or not a reference, it's a owned string. That's weird. Hold on. Content type header array is not supported. String index out of bounds exception, an empty response, and then header array is not supported. What on earth? String index out of bounds. What? Elasticsearch. What? Getting 500 error in ES 5.0. Yeah, I feel you, man. There are two slashes at the beginning. Okay. String index in a range. So I got the URL construction wrong somewhere. Build URL. Yes. Oh, that's it. Yeah, it is the double slash. I put a slash on the end of this and I really shouldn't have. Okay. Build URL, slash. Okay. Alright, I think okay. No handler found for URI Twitter. Method post. Header array. Alright. Content type header array is not supported. Alright, let's Oh, I need to set content type application JSON. Nuts. Alright. Hyper rs and request headers mute. I think that's what I need. Unless they're going to give me a set header method. Nope, they're not going to do that. Alright. So I have to get a mutable reference to the headers. And set the content type. Alright. Fields omitted. Great. Awesome. Don't bother to tell. Oh, it's a vec map. Okay. Header name and item. What's a header name? Header name. It's wow. It is a new type of ASCII of a copy on write, the static lifetime of a string. Really? I pretty much just need that code. So let me just shove that up there. And then we want to get the headers mute reference. So let mute headers equals rec.headersMute, headers.set content type JSON, and we'll rerun. Use of undeclared. Okay, yeah, I need to get content type from somewhere. Alright. Where's content type? Content type. Use hyperheader content type. Use hyperheader content type. Move out of rec occurs here. Borrow of rec occurs here. Yes. Alright. Rec.headersMute. I borrowed rec there. I think I can scope the borrow that way. Yeah, that worked. All right. Alexi, do you understand why I had to do that? Okay. So what I just did was I put the curly Q brackets around this let mute headers.set, right? Also, I'm getting new and interesting errors. So something changed, and that's good. Oh, acknowledge true. Yeah, okay, we're definitely getting closer. Anyway, sorry. So we have a mutable, borrowable reference to this request right here, right? Now, when you do rec dot, it's going to borrow itself, basically. You see how the self here is annotated with borrow mute? So it's borrowing a mutable reference. Now, one thing to realize is that this dot operator in Rust is basically insanely overloaded with a bunch of different things it can mean, right? And one of those is that Rust will just figure out the correct way to borrow or whatever your self-reference, whatever is needed to make that work, basically, so that you don't have to manually kind of figure out how to invert it and flip it around and turn it into just a normal function pass with an ampersand, right? Okay, so you see how down here when I did let mute s, I had to do that same curly bracket thing. The reason is because when I was doing s.pushStir here, I was basically borrowing the s under that lambda right here, the little block lambda. But the problem is that what I wanted to do was well, originally the code was printing s, but here I'm just returning it, right? The problem is that I don't, as far as Rust knew, s was still being borrowed by the time it got here. Even though I know that by the time this is done, it's done, right? So I can't say exactly why this is needed in some cases, but it seems to happen with mutable, borrowable references. Basically, you have to demarcate the scope of the borrow by creating a temporary anonymous scope with the brackets. And I had to do the same thing here. I had to say, I only need this particular borrow of rec for this long. And once this bracket closes here, that borrow is done, and now it can be borrowed again, right? Because I have to borrow it again for the rec.set body, and then later for the client request. So that's why I had to do that. Okay. I think we're getting close. I feel like we're getting close. I could be entirely wrong, but I feel like we're getting close. Alright, so compressor detection could have been called on some content bytes, not X content exception. Alright. What is this? Problem with the mapping, it says. This error occurs if you pass in a string instead of a JSON document to the body and data key. What? Let me see here. Alright. Sounds like Alexi needs to hit the sack, which is fair enough. It's getting pretty late. I should actually stop here, because one of the best practices when working on projects is when you end for the day, end with something undone. Don't ever end the day with everything taken care of. So, the reason for that is that it makes it so that when you go to start back up later, it's easier and quicker, because you already have that undone thing that you know you want to do, or that you know how to do. So, on that note, I will call it a night now, and pick this up where I left off next time. Thanks everyone for watching. It's pretty late for me as well, so I'm probably just going to go chill and read with my dogs for a bit, and then call it a night. Thanks everyone.